Okay, for this first example, we're going to find the derivative of f of x equals 5 cosine x plus x to the 7th power. So this 5 right here is a constant, and it's just going to be carried all throughout all of our work, and it will be part of our final answer, so we can just leave that one alone. The cosine x, well, let's just take the derivative. And this dx right here verbally just means I'm taking the derivative of cosine x. I'm not adding anything new. And the derivative of cosine x equals negative sine x. This will always be true. The derivative of cosine x will always be negative sine x. So now let's move on to our final part, the x to the 7th power. And the formula that you use for exponents like this is n x n minus 1, our n being the 7, right? So if we plug in our 7, we'll get 7x and then 7 minus 1. So 7 minus 1 equals 6. So our final derivative for x to the 7th power would be 7x to the 6th power. And now we just put these together. So the derivative of x equals negative 5 sine x plus 7x to the 6th power. Remember, we just brought that 5 down. That negative sign comes from our negative sine x, and then we just plug in the 7x to the 6th power. So that's all for this one. This next example, we're going to find the derivative of f of x equals 9x over cosine x. And for this problem, we're going to use the quotient rule, which is denoted as such. F of x over g of x equals g of x f prime of x minus f of x times g prime of x. All of that over g of x squared. Okay, so first let's separate this. So our 9 of x is going to be our f of x, and our g of x is going to be the cosine x. So we're going to need the f of x, which is 9x, f prime of x, which would just be 9, our g of x, which is cosine x, and our g prime of x, which is negative sine x. Remember, we went over this in our previous question. And now it's just about plugging everything in. So we're just going to use this formula and plug in everything. So we're going to have cosine x 9 minus 9x minus sine x over cosine squared x. And it's a little bit scrambled right now. It doesn't look very good, so we're just going to reorganize it to make it look a bit better and put cosine. Oops. We're going to put 9 cosine x plus 9x sine x, because this negative times by this negative would give us a positive, and all of that would be over cosine squared x. And this would be our final answer. For this next one, we'll find the derivative of x to the 5th power plus 10x plus 13 times x squared plus x to the negative 7th power. So for this example, we're going to use something called the product rule. And the product rule is denoted like this: 5 prime of x times g of x plus f of x times g prime of x. Okay, so our f of x will be this first portion right here. So I'm just writing that down. X to the 5th power plus 10x plus 13. And our g of x will be the second portion, which is x squared plus x to the negative 7th power. So now let's take the derivative of both. So f prime of x would be 5x to the 4th power plus 10 plus 0. And then g prime of x would be 2x plus negative 7x minus 8. Okay, which would just get rid of this positive right here and leave a negative, but I'm just writing it all out. So if we plug all of that back in, f prime of x would then be 5x to the 4th power plus 10 times x squared plus x to the negative 7th power plus x to the 5th power plus 10x plus 13 times 2x minus 7x to the negative 8th power. So it's basically just about dividing everything into the f of x, the g of x, the f prime of x, the g prime of x, and then plugging it all into the way the product rule is denoted. So this right here would be our final answer for this one. In this example, we'll be finding the derivative of cosine times 10x to the 3rd power. So for this example, we're going to use something called chain rule. And the chain rule is f prime of x equals f prime g of x times g prime of x. So just like our other examples, we're just going to find the first portion right here. So f prime of g of x would just be negative sine 10x to the 3rd power. So we're keeping this interior the same because it's just asking for g of x, but then it wants the prime of the f, which would be this one. So the derivative of cosine is negative sine x, and that would give us this. The second portion, so our g of x is just 10x cubed, but the g of x, g prime of x, would be 30x squared. So all put together, f prime of x would be negative sine 10x cubed times 30x squared. That would be our final answer. Okay, this one probably looks intimidating, but it's actually very simple to do. So the first step for this one is to convert all roots to exponents. Because when we work with exponents, it's much easier to take the derivative. So we're going to be rewriting this one, and this one. So for this step, the equation is the same. We're simply changing all of the roots to exponents. So we'll still have 2x squared plus, and then this root would be x to the 1/2 power plus 9x to the 1/3 power minus x to the 1/4 power. That's it. This one and this one they're equivalent to each other. We just rewrote the roots as exponents. And then the next step would be to take the derivative. Okay, so f prime of x would be, for this first term, remember we just bring the exponent down, time by this number right here, and then take 1 away from the exponent. So if we're bringing the 2 down and we're multiplying it by the 2 that's already there, we would just get 4x, and then 2 minus 1 would just be 1, so that just leaves 4x. For the next term, we bring down the 1/2. We keep the x, but we take 1 minus 1 from the 1/2, which would give us negative 1/2, plus we bring the 1/3 down, which would leave us with 9/3 x, minus 1 would give us negative 2/3, minus 1, we bring the 1/4 down, 1/4 x, minus 3/4. And this would be our final answer. And remember from, I think, the very first derivative that we found, the equation that I was using, to take the derivative of an exponent, we just do nx n minus 1. That's the formula that I used for each of these, to take the derivative for each of these. But this right here would be our final answer. Okay, this will be our final example for this video, but it's going to be a long one, but this is also the type of question that's typically on exams, so let's pay attention. So again, these roots are really hard to work with, so the first step will always be to change all of the roots that we do have into exponents. But because each of these roots is also in a fraction, that complicates things a little bit. But first, let's just focus on this first term right here. We're only going to be focusing on this. So 4 over the square root of x cubed. So let's just focus on the x cubed portion, just the root. So if we rewrite this as a fraction, it would be, as an exponent, it would be x to the 3/2 as the exponent. Okay, but then we have to bring in that 4 again, the fraction. So the final number would be 4 over x to 3/2 as the root, as the exponent, sorry. But fractions are also hard to work with. So if we rewrite it again, we'll get 4x to the negative 3/2 as the exponent. Yes, I'm sure that's confusing, but all we did was take this term, focus on just the root, change the root to an exponent format, remember to put it back into the fraction right here, and then rewrite it without a fraction. That's it. And when you rewrite it without a fraction, it just makes the exponent negative, as you can see right here. Okay, so now let's move on to the next term, which is this one. 2, 6, next fourth. X to the 4th power put into a root. Okay, so same thing. We're going to focus on just the root, which is x to the 4th power, rewrite that, which would actually be x squared. So that one's pretty simple. We're going to put it back into the fraction, which is 2 over 6x squared. And maybe you can already see it, but that simplifies to 1/3 x squared. And if we rewrite that, it would be 1/3 x and negative 2 as the exponent. Okay, now we can move on to our final. And that one's not, this final term, 1 over 9x cubed, is not an exponent, but there is a way to rewrite it to make it a little bit easier to work with. So we'll just pull out the 1/9, the fraction, and then put x to the negative 3 as the exponent. This will be easier to work with. So all that we've done so far is rewrite every single term in our original equation as change everything into exponents and remove any fractions that were unnecessary just to make it easier to work with. So right now, our next step is just going to be to write all of them in exponential form. Okay, so that would look like this. F of x equals 4x negative 3/2 as the exponent plus 1/3 x to the negative 2 plus 1/9 x cubed with a negative. Okay, so this right here is equal to our original function, just rewritten in exponential form. So it's only now that we can take the derivative. So that would look like this. F prime of x equals, I'm going to write it in a way where everything is, I'm not going to simplify it yet. So it's just going to be 4, and we're going to bring down the negative 3/2 x, take minus 1 from the 3/2, which would give us negative 5/2. So that's what we get from our first term. And then our second term will have 1/3, bring down the negative 2 x, and then from the original exponent we're going to subtract 1, which would leave us with negative 3 plus 1/9, bring down the negative 3 x to the negative 4th power, because we're subtracting 1 from our original power, which is negative 3. So now we can simplify and times these two terms together. So our final answer will be f of x equals negative 6x 5/2, negative 5/2 minus 2/3 x cubed, but it's a negative, minus 1/3 x to the negative 4th power. That would be our final answer. So we were given a function with a lot of roots. We changed all of the roots that we could into exponents, maybe reformatted a different term. We rewrote it as an exponential form, and then we took the derivative. And this right here is our final answer.